Hello students, today we are going to see the theorem from the topics triangle. Now, since the theorem is from the triangles topic, so definitely it is applicable only with respect to triangles. Now, what is the name of the theorem? The theorem is named as basic proportionality theorem. Okay, so proportionality means there is a relation between the sides which are in the same proportion. Now let us see what the theorem says. The theorem says if a line is drawn parallel to one side of the triangle. So definitely let us draw a triangle first. Okay, and name it as A, B and C. A line is drawn parallel to any one side of the triangle. So I can draw the line parallel to AB, AC or BC. Okay. So in this situation, I am considering a line DE which is parallel to BC. Okay. Which intersects the other two sides in distinct points. The line which you are drawing parallel to BC has to be intersecting the sides AB and AC in two different points. The other two sides means leaving apart the side to which you have drawn the line parallel. So currently I have drawn the line parallel to BC. So leaving BC, the other two sides AB and AC. So the line has to intersect the two sides at two different points. In this case, it is intersecting AB at D, whereas it is intersecting AC at E. If such is the condition, then the other two sides are divided in same ratio. According to the condition, if you draw a figure, the other two sides are divided in the same ratio. It means AD upon DB will be equal to AE upon AC. Okay, so now let us write down whatever is given. So whenever you are proving any theorem or you are solving any problem of geometry, always write what is given and what is to be shown or what is your prove that. So in this case, what is given? See, the first statement, whatever is written, that will be a given statement. Now you have to write that statement with respect to your figure. So since I have drawn DE parallel to BC, so that will be my given information, right? DE is parallel to BC. Further, they are intersecting in two distinct points, so that we are not supposed to write it. Now, what will be your prove that? To prove, yes, this last statement of the theorem which says the other two sides are divided in same ratio. It means AD by DB is equal to AE by AC. That you have to prove. Okay, so my prove that will be AD upon DB is equal to AE upon EC. Okay, so let us see how we can prove this. Now, as you have to find the relation between the lengths, right? So whenever you have to find the relation between the lengths, you have to use the areas of that respective figures. Okay, so now I want a relation between AD, DB, AE, EC. Okay, so now let us see where is AD, where is DB, where is AE and where is EC. So I have to frame the equations in which this respective lengths are present. Yes or no? So if I consider this length AD, how can I make an equation in which AD is present? What if I take area of triangle ADE? Now whenever you are taking area of triangle, definitely you should be having a base and height. In this case, I want AD in my equation, so definitely I will take AD as the base. But what will be the height for AD? Yes, so for that we will be making one extra construction. Now if you are considering AD to be the base, definitely your height should be the one which is falling on that base, perpendicular height. Okay, so now let us draw EM perpendicular to AD. Okay, so your extra construction would be draw EM perpendicular to AD. Okay, fine. So now let us frame an equation. The first equation would be area of triangle ADE is equal to half into base is AD and the height which is falling on it is EM. Right? Now I want DB also. For meanwhile, let us keep DB aside and let us see what about AE. Now again, AE is the side of the same triangle ADE, isn't it? So if again I write area of triangle ADE, but in this case I am taking AE as the base. Fine. So again I will be drawing one perpendicular height which is falling on AB. Let us name it as DN. So your extra construction, draw DN perpendicular to AE. Okay. So what will be your area of triangle ADE? Yes, in first case, area of triangle ADE was equal to half into AD into EM, right? In second case, your area of triangle ADE is equal to, now I am taking the base to be AE, so what will be my height? My height will be DN. Okay, so now you have got two equations, both are area of the same triangle but with respect to different bases. Okay, so if I look at the left hand side, I have got AD, and if I look at the right hand side, I have got AE. So the thing is, I don't want EM, DN also the half part. Okay, now look at the other side which we want in our ratio, that is DB and EC. Now nowhere we have made use of this condition, that is DE is parallel to BC. Okay, so nowhere we have used it. Definitely if it is given, so there might be some use of it. Yes, every information given has to be used in solving the problem. Now let us see, DE is parallel to BC. Fine. In my relation, I want DB and EC. Let us join BE and CD. Okay, so once you join BE and CD, can you see there are two triangles forming? One triangle is DBE and the another triangle is DCE. What is the relation between the areas of the triangle? As these two triangles are forming between the same parallels, isn't it? DE is parallel to BC. So the two triangles are forming between the same parallels. Also, they are having one common base, that is DE. So according to the theorem, it says if two triangles are lying between the same parallels and having a same base, their areas are equal. Okay, so by that condition, let us write, since DE is parallel to BC and DE is the common base, therefore area of triangle BDE is equal to area of triangle DCE, isn't it? Okay, so this was a theorem which we have learned in your previous class 9th standard, that is area of parallelograms and triangles. Okay, now next part, let us see what could be the formula for area of triangle BDE with respect to base and height. Coming back to the triangle BDE. In my relation, I want BD or DB. Okay, so can I write area of triangle BDE as half into taking the base BD. Now what will be the height for that? Yes, do we need to draw again one height construction? Let us see. Now BD and AD are actually the same line AB. Fine. So whatever is the perpendicular height falling on AD, that will be the same height for BD also, because for this same line you are not drawing two different perpendiculars. There will always be one single perpendicular. Okay, now you also know that it could happen that the height of any triangle could fall outside the area of that triangle, which is the happening in this case. Triangle BD is this triangle, but the height is falling outside the triangle. So even this condition is applicable, isn't it? So AD and DB are actually one and the same line. Hence, the height which is falling on AD will be the same height for BD. So what I could write here? Half into base into height is EM. Okay, let me write down this side. So area of triangle BDE is equal to half into base BD, or let me write down it DB, because in our prove that we have written DB. So let us write down DB into height, which is EM. Similarly for DCE also, if I take EC as the base, so which is the height which is falling on EC? Again, DN is the same height. Why? Because AE and EC are the same line, isn't it? So whatever is the height falling on AC, the same will be falling on EC. So area of triangle DCE will be equal to half into base, which is EC, into height, which is falling on AE, that is DN. Okay. Now, as you can see, we have got four equations. 1, 2, 3, 4. In four equations, we have the respective distances which we want in our ratio. Here I have got AD, here DB, here AE and EC. Okay. Now the thing which we don't want in the four equation is this half part and EM, EM, DN, DN. So how can they cancelled? Yes. What if I write this equation by this equation? Okay, let us divide it. Similarly, AD by DC. Okay, let us write down. So area of triangle ADE divided by area of triangle BDE. What it will be? Half into AD into EM divided by this one, half into DB into EM. So EM gets cancelled, half gets cancelled. Okay. Similarly, on the other side, divide ADE by DC. So area of triangle ADE divided by area of triangle DCE. Again, half into AE into DN. So AE into DN divided by half into EC into DN. Again, half will get cancelled and the heights will get cancelled. So what you have got? On this side you have got AD by DB, and on this side you have got AE by EC. But how do we know that these two equations or these two divisions are equal to one another? Yes, how can we say? See, as you can see, the numerators on both sides. On the both side, ADE and AD is present, right? Let us see the denominator. On one side it is BDE and on other side it is DCE. And just now we have proved that BDE and DCE are actually equal in area, which means the numerators are equal as well as the denominators are equal. Okay, so what does that mean? If the left hand sides of both the divisions are same, definitely their right hand sides will be equal, isn't it? So let us write down. If we mark this as our first equation, we can say from equation 1, I can write area of triangle ADE is upon area of triangle BDE is equal to area of triangle ADE upon area of triangle DCE. Okay, and hence if these two areas are equal, it means their right hand sides are equal, and therefore I can write AD by DB equal to AE by EC. Okay, so this is the proof for the basic proportionality theorem. So that is what we wanted. So what does the theorem say? It says if you are drawing a line which is parallel to one side of the triangle intersecting the other two sides at two distinct points, then that line is dividing the sides in same ratio. So AD by DB upon AE by AC has to be proved. So what we have done, we have made one extra construction. We have drawn EM perpendicular to AD and DN perpendicular to AE. Now EM, even though it is perpendicular to AD, but since AD and DB are the same line, so that perpendicular will be for line DB as well. Similarly, DN, even though it is perpendicular to AE and EC are the same line, so DN will be perpendicular to EC. Now we have framed equations of areas AD. In first case, I have taken AD to be the base, so height will be EM. Similarly, in second case, I have taken AE to be the base and the height would be DN. Now, in next part we have proved since D is parallel to BC, so DBE and DC are the two triangles with same base and between same parallels, though their areas will be equal. Okay. Now framing the equations for their areas, taking DB as the base, height would be EM. For DC, taking EC as the base, height would be DN. So we have divided these two equations. So half of gets cancelled and EM gets cancelled. So I have got only AB by DB, and on this side I have divided AD by DCE, and therefore half of will get cancelled, DN will get cancelled, and we have got AE by EC. But we didn't know whether the two equations are equal. For that we have to make use of the areas which we have shown as equal. Their numerators are equal and also their denominators are equal. Why? Because the two triangles are between same parallels, and hence if their LHS is equal, their RHS would also be equal.